Good evening everyone. So today we are going to start with an important topic. Here we are going to learn lots and lots with lots of fun as well. So in the beginning, let me ask you a question. In the present scenario, what you think it's very important where we cannot live without? Exactly, this electronic gadgets. So the world has changed that all our lives put up into a small gadget. Same as in the beginning, when there was the old civilization, people started finding small things, after that they have started discovering a very big thing, and they made us to live a sophisticated life now. So the basic source for all this started with light here. Okay, so for today's topic it is light. So which is the basic source of light? Which one you can say? Exactly, it is sun. So sun gives you two things. One is light and one more is heat. Here the topic which we are going to cover is light. In light we have a number of subtopics, and in that we are going to learn about mirror and lens separately. Before that, where this mirror comes and where this lens comes. Yes. So first see, the sun is giving a light ray like this. Okay, it spreads up light towards from one top. Okay, from one end it spreads light to the whole world here. So you just imagine I am taking only one ray. This is called as a ray, right? I am going to take only one of the ray which sun is giving, and here I am just keeping a surface. Okay, I am just placing a surface. Okay, same as in this side also, I am taking one ray. Towards my left I have taken one ray, and towards my right I have taken one ray. So here same as I have kept another one surface. But I didn't say what surface I have placed here. So here you just imagine I have placed some tiles. Okay, whatever it is in your house, many of your house you have tiles at your home. So same here, I am just placing a tiles. Okay, just an example. And here in the surface I am just placing a prism. Hope you have enjoyed the colors, right? In your previous classes you would have read about this Vukjya, dispersion, constituent of light and all, right? So here I am just placing a prism over here. What will happen? Do you have any guess? Exactly. So when this light ray, okay, so I can name this ray as incident ray, right? So whatever it comes, we'll just, nowadays it becomes very familiar, hashtag with all those names. Whatever we do, even if we laugh loudly, we just give some hashtags for that. Same as here, this ray which is coming from the sun. So how can I denote that? With the arrow mark. Okay, so it is coming towards the surface what I have placed, and once it hits the surface, what happens, you know, this bounces back in this way. Okay, it bounces back. So this ray we call as reflected ray. So I said incident ray and reflected ray. In motion you would have read about this action and reaction. If certain action is happening, for sure there will be a reaction. Same as here, this incident ray is the action, and the reaction for this incident ray is reflected ray. And in which way it is reflecting? This side. So the arrow mark, I have to denote this with the arrow mark, right? And this is incident ray and this one is reflected ray. Totally this is called as reflection. Okay, it is called as reflection. And in case, if in biology, if they say about the human anatomy, what you will say? You will say about eyes. Inside eyes we have a number of parts, and if you say our hand has elbow, joints, all those things. Same as here, this reflection, the basic here is incident ray and reflected ray. But still, to show the difference, I draw a perpendicular here to the surface. Okay, I am drawing a line. This line is called as normal. Okay, this line is called as normal, which I have drawn perpendicular to the surface. Okay, perpendicular to the surface. We can just name this, right? This is A and this is B and this is C. As this is normal, we can make it as N, right? And now what happens generally when it goes like this, when it's a straight line, it won't create any angle. But when it is slanting, okay, when it is like an inclined plane, probably it will form an angle here. So same as here two angles will be formed. The first angle, from where we are getting this angle? Incident ray. So we can call this as angle of incidence. And here what you can say? Exactly, angle of reflection. Sure. Next, so as I said, like anatomy, we can make this very simple. See, this AB, what is it AB called as? Good, that is incident ray. What is incident ray? From any of the source. Here we can say the sun as a source. So from the source, I am getting a ray which I name it as incident ray. Right. And next, what is BC here? BC is the reflected ray. When this reflection happens, when the ray, which ray? When the incident ray hits the surface. That's very important. When the incident ray hits the surface, then it is called as reflected ray. Good. Next we will just say about BN. What's BN I said? Good. It is normal. So what is normal here? The perpendicular line to the surface, right? And next we have angle I. So where do you think that with only one line I can draw an angle? No, it's not possible. So the angle will be formed between two lines here. What are those two lines here? One is the incident ray and the second one is the normal. So this is actually called as angle of incidence, right? But where it is formed? The angle between the incident ray and the normal. Good. And next thing here, it is angle R. It is called as angle of reflection, right? So where it is formed? It is between the angle between the reflected ray and the normal. So that is called as angle of reflection. And this center line, just we can name this as O and P, right? So this OP, which is called as the surface, right? Or we can call it as, okay, let us make it as surface. So this is the anatomy, as we can say. Incident ray, the ray which hits the surface, and in reflected ray, the ray which bounces back, and normal, the line that is perpendicular to the surface, and angle of incidence is angle between the incident ray and the normal, and angle of reflection is angle between the reflected ray and the normal. Okay, this is very important here. And how we can define reflection here in a short way? Okay, we can say reflection as bouncing back of light rays. How you can call this? Bouncing back of light rays. Good. So this is called as reflection. Right? Is it clear? Yes. So now in the beginning I said that we use mirror in one case. Exactly for reflection we can say mirror here. So the example for reflection we can take is mirror. As this mirror is of two types. One is concave and one more is convex. See, to differentiate it very easily, concave here is which is curved inwards. Okay, concave means curved inwards. See, it will be like a curve-like structure, like a cave. When we enter the cave, how the door, it will be having an opening, right? It will be having a curve shape, curve. So here we can say concave. For the cave, how the opening will be. So that it is a concave mirror, which is curved inwards. When it comes to convex, here it is curved outwards. Okay, curved outwards. In the concave mirror, where inwards, this will be a reflecting surface. When you take convex, this will be a reflecting surface. What is the surface called as? Reflecting surface. Yes. So this is the basic. These are the basics for reflection, and we have certain rules to be followed for drawing a ray diagram. There are 4 rules which we actually follow here. So the first rule, okay, so let me erase this and I'll explain you after completing about the reflection, right? So here the first rule what we are going to follow here is, see, I said, and with the help of a concave mirror. Okay, with the help of concave mirror. So this is the reflecting surface. Good. So this is the reflecting surface. Actually, I should not mention this with here, but here to show you reflecting, I showed this. Okay. So this is the reflecting surface, and here also you have another point which has to be followed. Before that, see, I have a mirror. The center point of the mirror is called as pole. Okay, or otherwise is called as vertex. Clear? And we will be drawing a straight line. Okay, that straight line is called as principal axis. Okay, and when you are writing this principal, you should be keen with the spelling. So it is P-A-L. It's not P-L-E. Principal axis. Clear? And then you will be having a focal length. Okay, and also you will be having a center of curvature. So after explaining the rules, let me say what is the focal length, what is the center of curvature, and principal axis. But the things you have to follow here, the 4 things you have, one is pole or the vertex, and it is also called, and next point is, it is focal length, then it is center of curvature, and a straight center line is called as the principal axis. Very good. So what I said now, we are going to follow 4 rules with the help of a concave mirror. So we said from any of the source we get the light rays. So you just imagine this is the source. From here a light ray which is parallel to the principal axis. What is this axis actually? This is the principal axis. So when a light ray parallel to the principal axis, what it will do? It passes through the focal length. So I told you to show the direction of the light ray, we should always use the good arrow mark. So from here it is moving and here in this direction. So what's the first condition here? Ray, okay, I am writing it small, parallel to principal axis, passes through, good, very good, passes through F. What is this F? Focal length. And next focal point, focal point. And second, so this is the first condition. And second condition here is same as I have a mirror, okay. So I have a center line. What is the center line? Principal axis. Here we don't want to denote this F, C and all, okay. So what is the second condition here I am going to do? First condition parallel. Second condition now, through F, a ray incident through F. Okay, what is this ray actually? This is the incident ray here, right? And after hitting the surface, this is the surface. So this is the reflected ray, right? This is the reflected ray. Now a ray incident through F. Clear? A ray. What's the vice versa of that? Yes, very good. So what I can say, when it is incident through F, what will happen? This will become parallel to principal axis. Yes. So you can draw. How you should draw the arrow mark? Will you denote? Yes, in this direction it moves and it comes out in this direction. Good. So here what happens? A ray incident. Okay. Ray incident through what? Through F. So what happens here? That will be parallel to principal axis. Very good. Yes. Now third condition. Same. We have a mirror. We have taken the center line. We have the C and F. Now I am going to take a source here. When a light ray passes through C. When a light ray passes through C. What is it? The C? C is the center of curvature. So when a light ray passes through C like this, here it will not hit somewhere like on this vertex. It means it will not hit on the vertex. Instead, once it reaches any of the surface, once it hits any of the surface, it will not be parallel, it will not move around, but it will retrace the path, okay? It will retrace the path. Clear? When a ray which passes through C. So, how you can write this? So, I will write this here. Through C, when an incident ray passes through C, it retraces. What does mean by retracing? So passing through the same line, it retraces the path here. And fourth case, so let me draw the fourth case here. So it's very simple. So here we said ray parallel, ray passes through F, ray passes through C. But in the fourth case, straight away the ray which I follow, it just hits the vertex itself. Okay, it hits P. So what happens here, when it hits P, automatically it reflects along like this. Okay, so how you can say it reflects in this path? So this is the way. So in this rule it explains you angle I, that is equal to angle R. Clear? Angle I, that is equal to angle R. Very good. So just we can recap this, and we can start with the laws of reflection. That's very important. And then we can see two different sets of ray diagram along with this rules. Okay. So what I said first, what is the basic source of light? Yes, exactly, sun. So what happens here? The sun, when it hits the surface, it bounces back. Okay, it bounces back. What happens? So what is the ray which comes from the sun? Incident ray. After hitting the surface, it reflects. Good. And what is the center line called as? Normal. Very good. So now the angle between the incident and the reflected ray is called as reflected angle of reflection. An angle between the incident ray and the normal is called as angle of incidence. Exactly. And then what is reflection? How we will define reflection? Bouncing back of rays. Bouncing back, it is bouncing back from a surface, right? So next, what are the rules? What are the two types of mirror we have? Concave and convex. Good. So what is concave? Which is inwards. Yes. So here the reflecting surface, that will be curved inwards, and here this will be curved outwards. Good. And in this concave, what I said, what we can take an example to identify. It's a cave-like structure. Good. So next, four rules. Before to have these rules, what are the things we need here? Mirror. In that mirror, pole, or otherwise it is called as vertex, principal axis, focal point, center of curvature. When a ray parallel to principal axis, when it hits the mirror, what happens? Passes through F. When a ray incident through F is parallel to principal axis, like 7. Okay, we'll do 7 like this, right? Maybe 7 like this. So this to this position, and again this to this position, right? L, no, not L, 7 and the inverted. Okay, so this is what? For the first two. And third one is through C, again through C. Through C, again through C. And fourth one, when it hits the vertex, what happens? Yes, it forms the same angle. That is, angle I is equal to angle R here. Right. So what I said, now we are going to start with laws of reflection. So we have two laws of reflection. We have to be very careful with this anatomy, right? What we have started in the first, okay? So the topic is laws of reflection. Okay, so the first law here is incident ray, okay, reflected ray, and the normal. That is also called as, that separation is also called as at the point of incidence, right? Incident ray, reflected ray, normal at the point of incidence. This is the point of incidence. This all lies in the same plane. So all lies in the same plane. So this is the first law. It's easy, right? Incident ray, reflected ray, normal at the point of incidence, all lies in the same plane. Good. Second law. What's the second law here is angle. The angle of incidence is equal to angle of reflection. That's it. This is the second law. Angle I is equal to angle R. The rule we have seen that. Yes, where it will hit? It will exactly. It will hit in the vertex or the pole. Clear? So these are the two laws. It's very simple. Angle I is equal to angle R. Incident ray, reflected ray, normal at the point of incidence, all lies in the same plane, and the angle of incidence is equal to the angle of reflection. Okay, so next we are going to start with the ray diagram. We can say, see, you have, with the help of concave mirror, we have 6 ray diagrams. In this 6 ray diagrams, you have 2 sets. So one will be the vice versa of other. Same as like that, we have 2 sets. So 4 can be learned easily. And through center of curvature when it comes, so that is also very easy. And last, it is slightly different from the remaining 5, which the image, see, the basic here is, now we just said there is a source. The source here, we name it as the source, which we are going to use here, we name that as object. Okay, that object we always denote with an alphabet U. And when I place the object, when you go stand in front of the mirror, will it be blank? No, it will show you, it will reflect you, right? So that is your image. That image is called as V. So with the help of this source, we have different positions. We said this P, F, C. So in these positions, sometimes we may place between C and F, sometimes we may place beyond C, sometimes we may place between P and F. So all those things will happen by placing the objects, or else even at infinity. I cannot say I can get from sun is infinity. I cannot go measure that rays from now. Okay, so that kind of things will also happen. So in that cases where the image will be formed. Clear? So where the image will be formed. That is what we are going to see in the next topic, which we call here as ray diagram.